Hello friends, how are you? Welcome to my YouTube channel. Today the topic we are going to cover is the directional couplers. But I think before covering this topic, it is better to understand the elementary physics which is being used to understand the topic properly. So friends, you know that if suppose some wave is propagating in that direction and another wave suppose is propagating from another point, suppose that point is A whereas the another point is B, and initially suppose two waves were uh, in the same phase like this, so it is suppose one way, so suppose this would be one way, here it was the another wave, so again it was another wave, and then there was a half wave, so but this is half wave. So by just seeing this example, you can see that by that point when the second wave, which is emanating from point B, reaches to some point P, actually has covered almost all the distance which was covered by the first wave from point A to Q. It means that this distance and this distance is same, right? So the extra distance which is being covered by the second wave, that suppose is the second wave, is this much distance, right? And suppose this is this much. So what is the difference? If you can see, so if you see these two waves, wave first and second wave, so you actually uh, draw a perpendicular from first point A to another wave which is going from point B to Q, and this suppose this point is some M point. Okay, so the extra distance traveled by the second wave, which is from B to point Q, is this much. Okay, and you can see here is that this is the extra wave, it is moving, okay, covered by the point second wave, and as the wave moves from one point to another like this, there is a change in the phase of the wave. So if you try to understand a wave, so suppose that is the first, when the angle is 0 at this particular point, and as the wave proceeds, suppose at point this, the angle here is 90 degree. Similarly, when the wave comes to this point, so that angle becomes 180 degree. Okay, and after that wave travels opposite in the opposite direction, right? So here the angle may becomes 270, and again when it completes its angle 360, a complete wave uh, is completed. Okay, so that is the full wavelength of the wave. Okay, so wavelength of a particular wave is lambda. So what we will try to understand here is that the extra distance traveled by the wave, like in this case is bm. Bm is the extra distance traveled by the second wave, and that is called the path difference, right? Path difference, right? So that path difference is actually responsible for the wave to have a phase difference, right? Phase difference. If suppose you will see these two examples and these two waves, wave 1 and wave 2, then you can easily see that the second wave is traveling uh, half wavelength, right, from point P to Q. That is the half wavelength. I already told you that if it is O to here, is suppose is going like this, so the total wavelength is this, so half wavelength is this much. Okay, so that is the half wavelength. So here it is covering this half wavelength. That is the path difference, right, which actually causing you to have a phase difference as well. Phase is basically the angle traveled by the, but like in this case, the wave has traveled from point O to some point here. Suppose that point is suppose some point A, right? So by covering this distance is lambda by 2, okay, and the angle, that is the phase difference, up to this point is 180 degrees, right? So in a way we can um, um, set a particular relation between the phase and the extra path traveled by the wave. Okay, so you can say the extra phase, extra phase suppose is uh, change in phi, okay, is basically some proportional to the extra distance traveled by the wave. So the extra distance suppose is delta x, because that is only a particular example where this distance or the path, or you can say this distance, is lambda by 2. In some another example, this x may be of different wavelength. Suppose this wave is like this. So here the wave is very small, right? And same wave suppose like would go like this. So in this case, the extra wavelength would be lambda, right? Okay. So similarly, depending on the wavelength of the wave and other thing, um, path difference shows a relationship between the with the phase of the wave. So that is to understand, and then we try to set a relationship between the path and the phase. Okay, so after setting the relationship between path and phase, we will try to understand the directional coupler. So friends, now let us try to establish a relationship between the phase and the path of a wave. Suppose this is a particular wave, okay, uh, and this wave has a time period from here to here, suppose is t. So the time period is t, okay, and the distance traveled, you already know, is lambda, okay, which is the full wavelength of a wave, okay, and the angle traveled from here to here, I already told you, here that is 0, that is 180, and here it is 360. 360 is nothing but 2 pi, and 180 can be written as pi. Okay, so that is the angle. So I already told that your lambda is directly proportional to your phase. So as the this path would increase, okay, 1 lambda, then 2 lambda, then 3 lambda, uh, something like that. Right? That would be 2 lambda. Then that would be 3 here. That would be 3 lambda. Okay. So as the lambda would, this path would increase, the phase would also increase. So let us assume that this path is lambda. So the angle traveled by this wave for a path lambda would be 2 pi. Okay. Likewise, suppose we have a particular distance x. Okay. Change in x, that is the path difference I already told. So that should be also directly proportional to the phase because of this analogy. Okay, so phase is phi. So you just can write this lambda is some k times of 2 pi. So k is any proportionality constant. Similarly, this change in x, which is the path, is k something change in phi. So just you divide equation 1 by 2. So when you divide it, so you'll have lambda by change in x is equal to, sorry, uh, 2 pi upon change in phi. So you can write that some angle can be, this path, lambda by 2 pi, or you can write 2 pi by lambda. Okay, so when you rearrange that particular equation, the 2 pi by lambda, okay, would basically be equal to change in x and change in phi. So basically change in phase would be equal to 2 pi by lambda into change in, that is the path difference, right? So in a way you can write this equation in this fashion. So change in phase basically is equal to 2 pi by lambda into change in x, which is the path difference. Now we would try to understand how this relation would be applied in the directional coupler. So before applying this equation, let us draw the directional coupler. and how it looked like, and then we'll use this equation in the functioning of the directional coupler. So now we have drawn a figure, a diagram for a directional coupler, but before proceeding further, I think it is better to understand the mechanism of the waves, how they can construct or destruct, and how one of the wave can be cancelled. Okay, so that we will do. Now try to understand, suppose there are two waves, and the waves suppose is meeting a particular point P, and these two waves are in the same phase. Suppose one wave is going in this direction and another wave comes at the same point with the same phase. Okay, so basically they are in the same direction, both are in the same direction. Okay, so it means that another wave would also come. So what would happen, that the new signal would be formed, and they will basically superimpose on each other and reimpose. Okay, so the strength of the wave would increase, right? But suppose what would happen if at that particular point, suppose another point is Q, and the two waves of equal magnitude interact at that point or incident at that point, but with opposite phase. Suppose one is going here and another is going here. Okay, so the phase is 180 and both are moving in the opposite direction, so the resultant would be 0. Okay, so the wave would destruct. Okay, or here that is the construction that would take place. Here is the destruction basically. Okay, so basically that comes into interference when constructive interference becomes, and other is the destructive interference, in which there is no magnitude. In destructive interference there is no magnitude, whereas in constructive interference the magnitude increases. Okay, so the same mechanism basically is being used in the directional couplers also. So we'll try to understand how this principle is being used here also. So suppose there are basically two holes, okay, in directional couplers. One is this one, which is called the transmission line, and another is below that transmission line, which is called an auxiliary line, right? So suppose transmission is being done here in the form of some waves like this. Okay, the wavelength would be same, and many waves are going, right? And there is a hole. Okay, so some waves would come here, some wave would also come here. Okay, so what we have done here is that this particular distance we kept as lambda by 4. Okay, so the length of this segment is kept such that its length is quarter of the wavelength of the transmission waves. So what would happen, suppose some wave is going here in this direction and enters to this particular hole. Suppose that particular hole is A. So that basically an example of two pinhole directional coupler. Okay, one is A point, suppose another is at point B. Okay, so some wave would come here, another wave would come here. So what would happen to wave which is coming down from point hole A? So it may go here in this direction, or it may go here in this direction. For the sake of some simplicity, suppose this wave divides equally in both directions. One is going here, another going here, right? So the same thing would happen to the wave which is coming down from point B also. Okay, so here also some wave would go in this direction and another wave would go in this direction as shown. Okay, so what is the extra distance traveled? Suppose this wave is your first wave, and this wave which is going from point hole B is your second wave. Okay, and just consider first of the example when two waves are going in this direction, because we supposed that particular wave which is coming from point A and hole B are splitting equally in both directions. But suppose let's try to understand uh, the splitted wave is going in this direction, from both the waves, from both the holes. Okay, so what would happen here is this wave, that is the second one, is traveling extra distance than the wave uh, traveling through the first hole. Okay, so or that extra distance is, first is this, which is lambda by 4, and another is this lambda by 4. From point, this distance for this wave which is coming here, and for this wave is same, this one. Okay, but this wave which is coming here is traversing extra distance, this one and then this one, before interacting with this wave. Okay, so what would happen, the extra distance which I already told, which is path difference for wave which is coming or reflecting back from the two holes, is lambda by 4 and again lambda by 4, so that would be lambda by 2. Okay, so what is the phase, I already told. So the phase in this case would be, I already told that the phase would be 2 pi by lambda and path difference, so that would be 2 pi by lambda into change in x, so which is path difference, and path difference is already I told is lambda by 2. So when you put here lambda by 2, so the path difference would be pi. Pi means the two waves are at a phase difference of pi, means 180 degree. It means one wave, phase of one wave, suppose at this point which is coming here, suppose that wave is your A. Okay, so first wave which is coming here is at a particular phase, we don't know what that phase is, and another wave which is meeting here, okay, first wave which is coming from the second wave is at a phase of pi, which is 180 degree phase difference. So that is this one. So what would happen here is, so anything which is reflected back from A and B are at a phase difference of 180, so they will, I mean the resultant would be 0, because they have a phase difference. And what would happen to the wave forwarding, the forward direction, means anything from hole A which is coming here in this direction and in this direction, so they will basically extra distance traveled by both. I think when these two waves meet here in this point, when here the path traveled by both waves is same. Suppose this first wave would come here, basically from here onwards they moves different path. Okay, so it would come here and then it would come here. Similarly for second wave it will come here and then here it will come here, so they will travel the same path, because these two are same and these two are also same. Okay, so there is no path difference, means change in phase would be 0. Okay, so change in phase would be 0 for this forward transmission of the wave in second one with the auxiliary line. Okay, so that would be, it means that the path difference between the two waves in that case would be 0. And what would be the phase difference then? 2 pi by lambda into change in x, so that would also be 0. Okay, it simply means that the two waves coming from two holes, okay, from hole A and B, will superimpose on each other. Okay, so they reinforce the magnitude of the two waves. It means that all the transmission or all the waves which has entered from A and B hole would come out of this hole. Okay, and here nothing will come out. Okay, here nothing would come out, or only waves would come here. Obviously the total intensity would be diminished. Why? Because some of the wave which was coming in the backward direction is cancelled out totally because of the change in the phase, and that only became possible because of the distance we have taken here is lambda by 4. If suppose this distance would have been different, in that case this would not be able to cancel each other. Okay, so that basically is the principle of directional couplers. And directional couplers are basically is used to uh, uh, measure the power, okay, transmission power, or the difference in the transmission powers. So that's it. So that is basically the principle, and I hope that that lecture would be sufficient to understand, and we'll continue to upload many of the interesting videos of these kind of subjects. Okay, so we'll continue the directional coupler. Some topics are also we'll cover on this subject. So thank you very much.